Hi, I'm Karina. Welcome to my lesson on triglycerides. So triglycerides are a type of lipid among which there are triphosphates as well. You can see that they have a glycerol. This is it here. And they have fatty acids combined to it. Right? Usually you might see something like an R signifying them as well. The main difference is that this has a phosphate and this is just, another fatty acid. That's actually where you get tri from. It has 3 fatty acids. If it was just 1, it would be a monoglyceride, or if it was 2, it would be a diglyceride, but it's 3, so that's where you get triglyceride. Note that they're macromolecules, which just means they're large and complex molecules, whereas with something like carbohydrates, they're just monomers and polymers of the same thing. But what is glycerol? Let's see. So glycerol is also known as, glycerin. Glycerine or glycerin. It's simple, as you can see from it only has 3 carbons here. It's organic. Oops. It's organic. You can see that from the carbon linked to other elements. But you could also see from the carbon that it's organic. And kind of gave it away here, but it's an alcohol as well. It's also triol, which means it has 3 hydroxyl groups, and you could also draw it like this or this. And what's a fatty acid? So firstly, it's a carboxylic acid. You can see from the carboxyl functional group here. You could also draw it like this or this. It also has a hydrocarbon tail. You could draw that like this as well. And it's insoluble in water. So this is, a donut here, which is obviously not fat, but it has fat in it, so it's floating on the water. Okay, fatty acids. So among fatty acids, there's saturated and unsaturated. The saturated has no double bonds, as you can see here. Unsaturated actually means that it's saturated with hydrogen. That would actually make it more solid at room temperature. While the unsaturated fatty acids have less hydrogen atoms due to the double bond here, which would tend to make them, liquid. Although with the cis fatty acids, both hydrogen atoms are located on the same side of the double bond, while with trans fatty acids, it's located diagonal. That in itself would change the properties. As you can see, the cis has a bend in it and the trans is straight. And since it's purposefully actually hydrogenated, like the saturated fatty acids, it tends to be solid at room temperature. Oh, and just a side note, it can have more than 1 double bonds in one of these and varying amounts of carbons. I only put like 5 in them. They can have a varying amount, which would change the melting point and therefore properties even when they form triglycerides and such. So back to triglycerides. Together, glycerol and 3 fatty acids attach to a condensation reaction, which I'll show you just now, to form a triglyceride. So let me show you. So condensation just means to remove water, right? So let's remove water, which is H2O. So H2O removed. So let's cross off the 2 H's and you're left with O. So it would become this. So let's try to do that for all of them. This becomes the bond right here. And this type of bond is actually called an ester bond. So this is an ester bond. So let's just put this back. Moving on. Triglycerides have a lot of uses that are pretty important. For example, around 95% of all dietary fats are triglycerides. So basically, we eat them. Let's see the next use. Energy stores. So it gets stored in the blood for later use, and when it's needed, it gets broken down, then released. So this is just a close-up of the triglycerides in the blood. And as you can see, it's stored. So if you store too much, it turns into fat, and then, you become more fat. So it would definitely be good to exercise to make sure some of that is burnt, so you don't have too much fat stores. It also cushions the body. It protects organs, bones, and other tissue from damage. As you see, his little pillow armor, this is supposed to be the fat. The fat deposits also insulate the body, so it's like a little coat for our body and organs and stuff. Right, so to break the bonds again, you actually just need to do something called hydrolysis. So you just add water. So this is me, adding water to the bond. And so the bond here is breaking. Yeah, good as new. Thanks for watching. Bye.